let me first off by telling everyone that today's actually super special. I mean, it's National Pastry Day, where we celebrate the pastry dough that makes amazing baked pastries. And personally, I love cheesecake, so this is definitely one of my favorite days. It's also National Llama Day. Believe it or not, there's actually a day where we celebrate the llama, and this originated in Canada. And to me, also very special, it is the fifth edition of what Powell just talked about, the Microsphere IT events. And this is the first one that I get to speak at, so I'm personally incredibly excited. And as we get started, I want to take you on a bit of a journey. And every journey obviously starts with the once upon a time in a land far, far away. But don't think that this is going to be a fairy tale. This is going to be something that is absolutely true. So think about your data center. Think about where you are hosting your applications, and that might actually be filled with a lot of monolithic applications today. And a few decades ago, even up to like 5 or 10 years ago, that was the de facto way to build applications. Simply, there was nothing else to build your applications as. And to be fair, I have nothing against monoliths, because a well thought out monolith to me will always be better than a very badly created microservice architecture. And the technology to build something now simply wasn't there. Our networks weren't fast enough, our CPUs weren't fast enough. And as we think about how microservices communicate, all those messaging protocols that we now use, they weren't there. They didn't exist, and everything that we had wasn't as reliable, as optimized. So over the past few years, we made significant improvements in technology. I mean, we built better networks, we built faster CPUs, we invented new messaging products. So we built a lot of better hardware. And ultimately, that allowed us to build better software faster. I mean, the combinations in network technology, in new CPUs, together with new protocols like REST JSON, like gRPC, all of that made it possible to use the available network bandwidth a lot more efficiently, and that ultimately allows us to build even more efficient applications. And as you look at it, the rise of projects like Kubernetes also made it possible to automatically make applications a lot more fault tolerant, a lot more high available than we ever could before. And I know I say automatically, but underneath the covers, there's a lot of work that still goes on. So with that, I personally believe that the one metric that is becoming the most dominant is time to value. Not so much time to market, but time to value. Because everyone, all the businesses, the ones that I work at or have worked at, and I'm going to guess the ones that you work at as well, are trying to optimize all the activities that they perform in order to deliver value faster. And the industry has made the shift to microservices to make it possible to get business logic out a lot faster than we ever could before, really decreasing that time to value. And at the same time, we started building new tools, new practices to really support building microservices. And to me, the interesting question is, why are we doing that? Why are we trying to optimize our activities to deliver value faster? And I think it can be summarized in like three major topics. We want to deliver value faster, to go from seeing data to taking action, to really spot and seize the opportunities with the ever increasing volume of data and devices. I mean, think about all the connected cars. We really want to make sure that we're not just seeing the data of, hey, this car is driving there with that speed, but we also want it to take action. We want it to stop at a stoplight or a traffic light. We want it to recognize the traffic signs. We want to get to market faster than ever before. And this is very much about the value to our stakeholders, to our CEO, to our boards, to our shareholders if you are at a public company. And in order to get them value faster, we have to deliver rapid innovation, rapid differentiation, because at the end of the day, we all want to be slightly different. And we want to deliver value faster to empower more people to build applications. We want to make sure that other teams within our company are becoming self-sufficient and help our business transform and in some cases even reinvent themselves. I mean, long gone are the times that every piece of development was done by the traditional IT teams. More and more is shifting to what Gartner calls the lines of business with bimodal IT and citizen developers. And in order to get there, we kind of need to build applications differently. We went from building these monolithic applications that talk to each other using technologies like enterprise service buses, like message brokers. And to be fair, I've worked in that business and it was amazing to see what people used to do there. But we need to be faster. We need to get to value faster. So we need to rethink how we're doing this. And that means that we're building applications as well as infrastructure that's based on APIs, that is based on event-driven patterns. And we do all that to support those three things I just talked about, to go from seeing data to taking actions, to get value into the hands of our customers, and to empower more users to build applications too. Now, if you're wondering who your storyteller is for today, as Paul introduced me, my name is Stigter, Senior Product Manager at Lightbend. I am passionate about things like serverless containers and generally all things that happen with application development. I love dad jokes, cheesecake, and Go. Though today's demo is going to be in TypeScript. So let me unpack the title of today a bit, Thinking Stateful Serverless. And this is a relatively new trend to me that is emerging, that's trying to decrease that time to value even faster. And this is really shifting the way that we build applications, that we connect applications. And as the industry, we're calling that serverless. So let's unpack it a bit, because serverless means a lot of different things to a lot of different people. So first off, I think that this quote by Gartner, which originated from the CIO's Guide to Serverless Computer, is amazing. It really talks about what serverless is, and surprisingly, that middle piece that I highlighted in orange is like the crux of it. Serverless isn't just hypervisors in an even more modern suit. It's really about moving the operational tasks to the cloud, so that developers can focus on what moves the needle for your business. So rather than dealing with the complexity of infrastructure that their code runs on, sorry about that, developers can spend their energy building awesome products that deliver value. And obviously that means you're trading a bit of control for abstraction, but at the end of the day, that is what allows developers to speed up their innovation cycle and really get from idea to development even faster. So generally speaking, there are four elements that that a serverless platform provides for you. And it all starts with no more servers. And I totally get that there are absolutely servers in serverless because it has to run somewhere. But the no more servers in serverless really means that there are no more servers to manage. So as a developer, you're giving up the need to manage servers, and in return, you get the flexibility to think about what adds value to your business process. So it removes the whole toil of OS patching, of server replacement, and things like that. At the same time, from a client point of view, it is all about flexible scaling with traffic. I mean, the platform that you run on really takes care of the scale of traffic. And as more and more traffic comes, then it should seamlessly scale up. And as that traffic disappears, then it should seamlessly scale down as well. Ultimately, it is about paying for what you use. So rather than thinking in server instances, you're thinking about what is the actual usage that I get out of this, either throughput, execution duration, or anything along those lines, rather than a server instance saying, hey, I have this rack of metal that I shove into a data center. And incredibly important is that it has high availability built in. And obviously, serverless means that developers don't have to build it into their application because the runtime takes care of it. It doesn't mean that you don't have to think about failures anymore. In fact, there are a bunch of new failure modes that, as you're thinking about serverless, you have to take into account. Because of automatic scaling, for example, all of a sudden you have to think about what's going to happen if my database is really slow. And if everything relies on a database and that database is slow, that is going to exacerbate the problem if I get a lot of traffic all of a sudden. Now, a lot of times people ask me, is serverless a real thing? And I absolutely think it is, because 41% of companies today are using serverless in production. And this is a number from the CNCF Kubernetes survey that they did in 2019, which obviously talks about the fact that they see a massive rise in how serverless is being used. And this number isn't just about what, for example, AWS Lambda does. This is all about the combination of hosted serverless like Lambda, but also the things that run much more on a Kubernetes cluster. And while fast is awesome, there are a bunch of challenges with it as well. I mean, developers use serverless and fast in general for a wide array of development tasks, ranging from building APIs using something like GraphQL or REST to building chatbots, and my personal favorite, automating DevOps tasks. And fast obviously reduces what a developer needs to do in order to get data in production. But at the same time, there are a bunch of challenges. And I think the most important challenge, or one that comes up a lot, is the limit in execution time. As you think about it, there are a lot of platforms that limit how long a function can run. For example, Lambda, at least as of today, limits it to about 15 minutes. So that obviously limits what you can do with it. And there is the idea of connection management. I mean, if I need to connect to, for example, a SQL database, then all of a sudden I need to think about how am I going to handle those connections. It is not the same as just putting in a database driver and doing a bunch of connection pooling. The other thing beyond connection management is thinking about the changes in data, especially once state is delegated to a database. If you don't think properly about setting up the access and update patterns, that is going to lead to increased latency, a bunch of runtime overhead, and a difference in what the users see versus what the users expect when they hit your API. And ultimately, all of the functions that we deploy, all of that serverless stuff still relies on state. And as apps are becoming increasingly data-centric and data-driven, the more traditional fast platforms are going to have a hard time supporting those use cases. As functions want to be more efficient, want to be more performant, and we as an industry want to provide a more reliable way of managing, processing, transforming that data, we need to make sure those functions can take ownership of the data. And that way, the apps can massage the data that they get, and obviously reducing the overhead of database round trips. So I talked about state in a bunch of these. Is state really that important? I think it is. And state is like, what is the data in motion that keeps your business running? And one interesting thing that just arrived in IDC's Global Datasphere report is that they mentioned that by 2025, nearly a third of all the data that is going to be generated will be consumed in real time by the services that we use. So to give that a little bit more flair, it is predicted that we will consume and produce 175 zettabytes of data in 2025. And 30% of that means that if we take the biggest SSD that exists today, which apparently is the Nimbus Exadrive, I had to Google that, I'll be honest here, that has a capacity of 100 terabytes, we would need 1.8 billion drives to store the amount of data that we consume in real time. Just think about how many drives that is. Think about how important it is going to be to keep the data close as possible to what we develop. So the challenge is to build your serverless applications in a way that you can leverage that data in motion as much as possible. And we all know that cloud native applications need to be responsive, resilient, elastic, and message driven. In short, modern applications need to be reactive. And as the company that brought you Akka, we thought that we want to solve that very complex problem. We know that Akka solves a bunch of the problems that we talk about. So what we want to do is we want to bring the power of Akka to every developer in whichever language they choose. And if you're familiar with Akka, let that sink in for a second, because that is a massive mission statement. The power of Akka, having everyone be able to use that power of distributed, resilient, elastic, message-driven architectures to every developer in whatever language they choose. So not just Java or Scala, but things like Node.js, things like Go. So we created two things, and I want to talk about both things. We created an open source project called CloudState. And what CloudState does is exactly what I just talked about. It allows you to create Akka clusters for your services without having to think about, how do I do that? How do I scale my Akka cluster? What happens when a service scales? And we also offer a managed service of that called Akka Serverless. So let me dive into that a bit. So what happens when a service scales? Now, first off, once you deploy, you actually deploy two parts. You deploy the container that you build, and we inject onto a Kubernetes cluster a CloudState proxy. And that CloudState proxy actually is an Akka node. So that means that once your service scales from, let's say, 1 instance to 3 instances, all of those proxies start to work together, and they automatically form an Akka cluster without you having to think about, what is it that I really need to do? So as an example, how do you build an application? And in our case, there were like 3 important pieces to building an app, and we'll actually get to that in a quick demo. So you need an API description, you need a state model to think about, how am I going to store that, and you need your business logic. So how do you build an application? We start with an API description, and in our case, we use a protobuf, simply because it works across languages. And if you start with an API description, then it actually avoids long drawn-out projects, because you know what you are going to implement, and someone else knows how they can call your service. Now, state models, obviously, if you're familiar a bit more with Akka, this is really about, how am I going to store the events that come in? And right now, there's a bunch of support for replicated entities or event source entities, and we're absolutely looking at both CloudState as well as Akka Serverless to implement a lot more of that. And at the end of the day, it is all about your implementation logic. And what happens in that logic is that you can tie your services to what you define in your gRPC to the actual services that you have, and that in the language that you want. So what I'm going to do now is I'm going to stop sharing my slides. I'm going to move this out of the way for a sec, and I'm going to open up my VS Code. And let me actually open up the other window where I have my Acme sunglasses project. And what I'm going to do is quickly walk you through all the pieces that we just talked about. Let me just make this slightly bigger so that everyone can hopefully see it okay. And I'm just going to open up the order service, because at the end of the day, everyone needs to be able to, in this case, order sunglasses. And as we talked about, everything starts with a protocol buffer. So in this case, I have a bunch of messages. I have the all orders message, I have the order message, and those messages essentially talk about, what is the data structure going to look like that I send in. So in this case, for the get order message, it's going to be a payload that has a field called user ID. and a field called order ID. And as you can see, for that user ID, it specifies a specific extra element here that is called the Cloud State Entity Key. And Cloud State Entity Key really means that within Cloud State, within Akka Serverless, how am I going to share the all those entities across the different services that exist? And ultimately, it comes down to building a service, if you will. And the service really describes what is going to be the actions that someone else can take, what is going to be the input, what is going to be the output. So if I look at add order here, then I can see that add order accepts a order message and returns a order structure. And there is this special option here, which says google.api.http. And what that means is that as I deploy this, Cloud State automatically makes this available as an HTTP interface on top of a gRPC interface as well. And in this case, what I can do is I can say, well, this is going to be an HTTP post method that I can post to /order/ and then what user ID it is. And I'm going to accept the entire body message. So this is great. I mean, this allows me to write out my interface contract and give it to, for example, Powell, so that he can build the front-end UI, and I can focus on the back-end implementation logic. Now, how do we tie this protocol buffer into something that actually works? So in that case, let's go into the JavaScript code. And yes, I totally understand that is absolute blasphemy from a company that is historically connected to Akka, to Scala. So, however, having said that, our mission was to make the power of Akka available to as many developers as possible. So having it available in different languages is absolutely the way that we wanted to take it. And in this case, what we do is we actually specify where the proxy that we talked about, where it can find the protocol description. And we tell it the behavior. So we actually tell it that if you receive a message, and in this case, it's add order, and I have the other ones that were listed in the protocol buffer here as well, then go execute this specific function in my JavaScript code. So let me actually scroll down a bit so that you can see what happens. And in this case, I get the add order message. So that's that JSON payload I was talking about. And I get the context object. And the context object is what is incredibly important, because that is how Cloud State and Akka Serverless as well is going to inject the data that you need at runtime. So rather than me having to go out to my database and do a select star or something along those lines to get the data of the orders that I want to massage, I can actually get the context before I turn it into before I actually do something with it. So I have the context, I have the order, and in this case, really all I need to do is just emit the order event so that the next time someone tries to view or check the orders, we can actually see what the entire context was. And obviously, as we talked about a bit, in a Cloud State environment, what you do is you deploy a container. So there obviously is a Docker file that turns it into a container, and then you can deploy it. So using the command line, I could do something like Akka SLS. You know what? Let me actually check first which services I have. So SVC or services list. And I can see that in my current project on Akka Serverless, I have three services. I have the orders, the users, and the warehouse, which is obviously great. And I can actually see a bit more data. So let's actually do get Acme sunglasses orders. And right now I can actually see what all that data is. And as you can see, because I specified the HTTP endpoints, it actually gives me a URL as well. So I can actually go to this exact URL send in the messages, and they will respond to me with whatever it was that the input was. So this is great from a command line point of view, but let me also quickly show you what that looks like once you see that from a UI. Because at the end of the day, CLIs are awesome. I mean, I prefer CLI over UI, but for management tasks, having a UI available is absolutely going to be important too. So let me open up my my Safari, go to Akka Serverless. Oh, let's actually drag that down here so that everyone can absolutely see it. And as you can see, I have 3 projects. One is called the Acme sunglasses, the one that we were looking at just now. So let me go into that. And I can see the three services here as well. I can see the orders, see the user, see the warehouse. And as we go into to orders, I can actually see everything that is deployed. So the cool thing is I can see which Docker container I have deployed. I can see which version, and more importantly, I can see how many commands my service has gotten. So I can actually see how much traffic is going on. So with that in mind, we actually allow you to, as a developer, only think about what is really important to my business. And if I think about the Acme sunglasses order service, the most important thing for my business is that I can log orders. So rather than thinking about the entire thing of having to spin up infrastructure, having to think about a database, having to worry about how fast it can respond and all that scale, I only have to think about one thing. So going back to my code, the only thing, oh, sorry, this one, the only thing I need to worry about is like this piece of code. I only have to worry about the add order part. And that to me is the power of Akka Serverless, the power of Cloud State, and ultimately the power of being stateful serverless. So with that in mind, let me show you just one more slide. And that's essentially, wow, that crashed faster than I thought it was going to be. And I ultimately lost my mouse. That's fun. So one last slide, essentially to thank you. I want to thank you all for joining us today at Microsphere IT. I want to thank you for listening to me ramble on about the importance of serverless and the importance of being stateful serverless. If you have any thoughts, any questions, then feel free to reach out to me on Twitter. My handle is @RedGits, which is essentially my last name in reverse.